Hi, everyone. Welcome to a new lecture of CS 124 Honors. Today, we will be going over the key concept of Git. So before we start off, some quick announcements. First of all, Project Kickoff will be on 3rd February. It is a mandatory event, and this is the event where you will be introduced to your team and to your PMs. So make sure that you attend. Secondly, if you haven't already, please join the Discord server and also make sure that you've renamed yourself on the Discord server. The preferred way to rename yourself is with your preferred name and then your net ID in brackets after that. Finally, if you haven't already, please register for the course by tonight. It is super important that you do so by tonight. So firstly, please fill out the enrollment confirmation form if you haven't already. This is super, super important because this is how we keep track of all the students enrolled in the course. So if you have not enrolled, you will not be able to participate in the course and you will automatically get an unsatisfactory in this course. So quick note again, for non-James scholars, along with the enrollment confirmation form, you will be required to register on self-service. So this is the class that you have to be registering for. It is CS 199, section 124, and the CRN is 54574. So please make sure that you've registered for this class on self-service along with the enrollment confirmation form being filled out. For James scholars, it is super important that you fill out your HCLA form. Do not register on self-service. You will not be able to. That is only for non-James scholar students. Along with your HCLA form, you will be required to fill out the enrollment confirmation form. So just in summary, everyone is absolutely required to fill out the enrollment confirmation form. Like I said, failure to do so will result in an unsatisfactory in the class. Non-James scholar students, make sure that you register for the class on self-service. And James Scholar students, make sure that you filled out your HCLA form. Okay, so that is it for logistics, and we can get started with our lecture content for today.
Awesome. So like we said earlier, today's lecture is going to be on Git. So we'll start off by answering the question, what is Git? So Git is a version control system. And a version control system is something that you'll see whenever you work in industry or across multiple different project management structures. It's used a lot across a lot of different companies. It's basically a system that tracks changes to project files, and it allows for developers to communicate easily and securely with each other. And you can also have file recovery options and so much more. Yeah, so Git is something that you'll also use in your classes going forward. Many classes in UIUC utilize Git for either auto-grading purposes, to have you save your code, share it with instructors, and so on and so forth. So it's a very important thing to learn. And this course will give you a good introduction to that. So how does Git work? To explain Git to you guys, as a very broad conceptual overview, we have an anecdote that we want to show that hopefully kind of goes over the broad details of Git. So let's take John, for example. John is a developer. He has written some amazing code, and he has it stored on his computer in a repository. So if you can see on the left here, we have John's repository. It's marked in red at the moment. And a repository is basically just a fancy word for folders. So whenever we say you have a repo on your machine or a Git repo, we're just talking about a folder. But now what John wants to do is he wants to share his code with his friends, his fellow developers. So what should he do? And the answer is obviously to use Git. So John would go and create an empty GitHub repository. So GitHub is a place where you can create Git repos, so you can utilize the Git version control system. So he would go to GitHub and create this empty repository. But the question is now how he would get the code that he has on his local computer into GitHub. The way he would do that is he would push his code to the repository. So there's some terminology that we're going to use from now on, and you'll see that it's they kind of go along with each other. So push is one of these words. Pushing code to a Git repository means that you are taking what is on your local machine and pushing and moving it into GitHub. So you are transferring the code that you have locally onto the remote server. That is what pushing means. So now after this process, you see that what John has on his computer, the red, is transferred over to the GitHub repository, which is also red. So now both John's machine and GitHub have the exact same code. So now that John's code is stored in the GitHub repo, we have one of his friends, Mary, who's interested in seeing John's code. So the question is now, how can Mary get John's code?
Okay, so a new terminology that we'll be using now is cloning a repository. So as we see, John's code is currently stored on GitHub, and now Mary needs to get it onto her system. So like we pushed it from John's computer onto GitHub, we now need to clone it from GitHub to get it onto Mary's computer. So as you can see, when she clones it onto her own computer, the same version of the code that existed on John's computer is now on her local computer as well. And what is cool about this is that the same exact version, like I said, exists on her computer. And so in this way, John and Mary have collaborated with each other, but this is done in a secure way. So there's no visibility between what is on John's computer and what is on Mary's computer. So now let's say that Mary has looked through John's code and she wants to suggest some changes to what John has implemented. So how can she do this without overwriting what John has written? This is done using Git branches. So if you think of Git like a tree, you can make different branches to essentially create different copies and suggest changes so that other people can review them and then merge them in the end. So Mary will create a new branch called, let's say, Mary Suggestions. And for now, the code is still the same because she hasn't edited it yet, but it's on a different branch. So right now, the pink color and the red color, those are two different copies of the same code because Mary hasn't edited it yet, but it's on a different branch. And now finally, Mary suggests her changes and she writes some new code to the existing code that John had written. And then she pushes it onto GitHub. So this is a new terminology again that we'll be using. And by pushing it back onto GitHub, she is now saying, okay, this new copy that I had, my branch, is now going to contain the new code that I made and the changes that I made. But it still, as you can see, has not overwritten what John has written. So there are these two separate copies. The only changes that have been made is on Mary's branch. And finally, so that she doesn't overwrite the code, and because they're both collaborating, they both need to have an equal say. So the only way that John's original code that he had put onto GitHub can be changed is if he looks over those suggestions and he says, okay, I like these suggestions, and he decides that he wants to merge Mary's suggestions into the main branch. So the main branch is what he pushed his code originally into, and now Mary's suggestions branches, if it's merged with the original branch, both of those copies are merged, and now the only copy that exists on GitHub is what Mary made. And finally, for John to have whatever he wanted onto his own system, the code that exists on GitHub onto his own system, he is going to pull whatever exists on GitHub, the main branch, onto his own system, and then so on and so forth. They can go between each other, create branches, and keep editing.
Awesome. So that was a very broad overview of some of the main important aspects of Git and aspects of Git that you will be using during your time in 124 honors. So we're going to go a little bit more into detail as to some of the terminology that we talked about. So one of the things we talked about was pushing. And pushing, like we said earlier, is when you have code on your local machine and you want to put that onto the GitHub repository. So how does pushing to a Git repository actually work? So here we have two different things, right? So we have our local repository. The local repository is what was on John's computer. It is the code that is running on his machine. Well, the other thing that we have is the remote repository. So this is on GitHub. This is where we're storing John's code. So GitHub is essentially a way for us to communicate between the local repository and the remote repository. So the local repository, when using Git, can be split into sort of three main areas. So the first thing is the working directory. And the working directory is basically the area where you are making all your changes. It is where you are writing code. It is where you are editing things. Once you are done editing and you are ready to make that operation to push onto GitHub, there are a couple of steps that you need to take. You need to first move your changes from your working directory to what Git calls the staging area. And the staging area is you can kind of think of staging area as like the backstage before actors perform. It is where they get ready and everything is kind of set before it is pushed onto the live performance, which in this case would be the remote repository. So we do that by doing a command called git add. So the git add operation takes all the changes that you've made and pushes those to the staging area. Now there's one more step before we are ready to push, and that is the commit operation. So this is like giving the final go before actors are allowed to enter on stage, right? So between the staging area and the Git repository, we need to make what Git calls a commit. And a commit basically tells Git that, okay, we have all the changes that we have made ready and in the staging area. We can now push them into the Git repository. So once you commit, and often when you commit, you will commit with a message that describes the changes that you made. So let's say you fixed an important bug that's making something on your website display incorrectly. You can have a commit message that says fixed message that is being improperly displayed. So that kind of gives all of your changes a label, a name under which they can be accessed through GitHub. Later on, for instance, if you make any errors while you're developing and you need to go back to a certain version, you can refer to it by the commit. Once you do your commit operation, you now go from the staging area to the Git repository. Then you can push, and you will be in your changes will now be on the remote repository ready and in the version control system ready to use. So here's just a quick summary of the commits that I had talked about earlier. So the first one is git add dot. So like we said, this moves your code from your working directory to the staging area. Git commit, and then the message, which is signified by -m on the terminal. And we will be demoing all of these commands later, so you will get to see how these work in action and what these commands are actually doing. So git commit -m, and then any message you want, basically creates a snapshot of your repository. It puts all of your changes under like a message, a certain area where you can access those changes, and it readies your code in the staging area to be pushed to the Git repository. And then lastly, git push, and then origin and the name of your branch. So like we talked about earlier with branching, if you don't want to push to the main branch, the root of your Git repository, you want to push it to a place where your changes will not affect other people's changes. You will push specifically to the branch, and you can mention the branch name while using that command. So the next topic that we'll talk about is pulling. This is also something we mentioned in our anecdote. So git pull is the command that we use when we're trying to pull changes from our remote repository into our local repository. So git pull will fetch changes from the remote area and merge them into the current branch that we're working on. And it will update the local copy that we have with the latest changes that we got from Git. So this is basically taking what the changes that Mary had made onto the Git repo and putting it on John's computer. So it is the opposite of a push. And the last thing that we can encounter is merging and merge conflicts. So if we go back to the example that Mary and John had. So let's say John pushes his code into GitHub and Mary pulls it. Mary is now making changes in her own branch and pushing that onto the GitHub repo. John likes these changes and he wants to integrate them into his own branch. So now that there's only one version of the code on GitHub. The problem that can happen is that changes that Mary had could be overriding certain lines of code that John had written. Let's say there is a certain variable in John's code that Mary relabeled. That relabel will cause a conflict when we are trying to merge the two branches together. So that is what merging is. It is the process of combining changes from different branches into one. And you will always be merging when you're working on different features or fixing bugs. Because ideally you don't want all your features to be on different branches of Git. You want to have it on one place in your code so that you have a cohesive product. And when you're merging, you will run into merge conflicts. So this happens when Git can't automatically fix changes for you. So that puts the strain on you as a developer to work together with your team member to fix these changes and see what needs to be in the final code base and what doesn't make it. So yeah, merge conflicts basically arise when you have multiple modifications to the same lines of code. So for that, you will need to resolve the conflicts. So you will need to work with your team member to figure out which lines stay, which lines can you discard, which lines will make it to that final merged branch. So that way, once you have merged the two branches, the one that you merged from no longer needs to exist because now all the code is on one branch. So now we will be demoing all of the things that we had talked about so you can see exactly how this works.
Okay, so here is a short demo on cloning the repository onto your local system, as well as making changes and committing and pushing them back onto the remote repository for your collaborators to view. So first I'm going to start by cloning the repository onto my system. The command that we use for this is called git clone. So I'm going to say git clone, and then I'm going to copy the link of the repository. And I'm going to copy the main link. And I'm going to say that. And now it's going to save it on a folder, which is named with the same name that my repository has. And it's going to be on my desktop because I'm currently in my desktop, as you can see. And so here we are, we have a little folder which has all the contents of the remote repository that I just cloned onto my system. Now we're going to edit sample.py and we're going to put it into our folder and we're going to push all of those changes back onto the remote repository so that my collaborator Rohan can work on the same file. So let's just make a quick change to sample.py. I'm going to say print hello world. Save that. So now I've just made a change to sample.py and I'm going to add that file into this first. So it is now inside my folder and I'm first going to navigate into this folder using my terminal. The command to do that is cd. So you just say cd and you say, so we can see that it's in my desktop. I'm currently in my desktop, as you can see. So I'm going to just say cd one. If you just type in a couple of characters and you say tab, you should see the rest of the name. And I'm just going to say cd into that folder. And so now, as you can see, I'm in that folder. I'm just going to say ls just to see if the file that I wanted has been moved into it. ls is just a command to list the different files which are within the given folder. So I'm just going to look at those. As you can see, there is a sample.py. There's also something called readme.md. This is just a markdown file that all repositories come with. A README is just a basic file which contains, like an introduction to the project that you can write. So when you're on your folder in the desktop view, which we saw earlier, which is what, we use the link to clone, you have a README where you can, talk about the details of your project. So these are the two folders that I have right now. So as we can see, sample.py is there. So we've made the changes that we wanted to make locally, and we're going to first now push them onto our main repository. And so the way we do this is like we learned, we have three main commands. We have git add, we have git commit, and then we're going to push it. I'm not going to be doing any branching here. So we're just going to be pushing onto the main branch. So let's first say git add. So like we saw, the command is git add space dot. So that adds all the changes. Next, I'm going to say commit, git commit. And you also want to say -m, which is just like a message tag to say, now I'm going to add a message like a string on what changes I made. So I'm going to say added file sample.py. And so it's committing that. And finally, I am going to push that. Okay, so it should be pushed. So now let's go look on our tree. So there we see sample.py. So our push has been successful, which is great. And before we started this video, we actually kind of played around with this demo. So if you see, there are like previous commits that we've made in the past. So for example, Rohan, he did an initial commit where he created the repository and we added a bunch of files, deleted them. And so as you can see, this is the last commit that we made. If you click on that, you can kind of see what change was made. So that is the main, beauty of the version control system here. You can see how the project has been changing. And if you want to, you can always go back to a previous version, revert back to a previous version if you made any errors in the future. So yeah, that's it for this demo.
Awesome. Hey guys, so I am Rohan. I'm Ranjini's collaborator on this Git demo, and I will be demonstrating to you how to retrieve changes that were pushed onto Git and some cool things with branching and potential things you might see when you're trying to merge branches. So as we previously saw in the demo, when Ranjini made a change to her sample.py file and pushed that onto our GitHub repo, I can see it from my side. So this is my GitHub account and I have access to the GitHub repo. As we can see here, Ranjini added this file, a sample.py, and when I click on it, I can see the line of code that she added, print hello world. So now, how do I put this code from the GitHub repo onto my local repository? And the first step that we do is the same thing we did when we were trying to push the repository. If we don't have the repo locally on our computer, we first want to clone it. So what I will do now is I will clone the repository. So I'm going to copy the link, the HTTPS link of this repository, and I'm going to switch over here to my terminal. The IDE that I'm using is Visual Studio Code. If you are not familiar with it, it is a great IDE for projects and for coding. You have in-house access to a terminal, and you can edit files directly in here as well. So it's very cool. So this is where I want to clone my repository. So I'm going to do the clone command. So I'm going to do git clone, and I'm just going to paste the repository link here. So it's going to take a second to clone. Awesome. So now it is done cloning. So now if I do ls, which will list all of the folders and files within my directory, I actually have a directory called GitHub, which is where I store all my projects that I clone from Git. You will see here that we just have successfully cloned our repository from GitHub locally onto our computer. I can see it on my terminal. So we want to now cd into that repository. So in this case, it's called CS124 honors, SP24 git demo. So let's put that over here. Oops, copied the wrong thing. I believe if I just start typing it, it should auto-complete with the name if I press tab. So now that I've done that, let's press enter. So now you can see that I am within the 124 honors Spring 24 repository. So now if I do ls here, you can see that the files that I have in here are the sample.py file, the README that Ranjini was talking about earlier. So these are all the exact same files that you'll see were here when that were in the original GitHub repo. Awesome. So now I want to open sample.py. There's a number of ways you can do this. In VS Code, I can just open folder and just kind of look at the code. So if I navigate my way to my GitHub folder, let me just do that very quickly. So we are in here, and I just want to open this folder. So give it a second to open. Awesome. So now we can see and edit the different files that we have. So we see that we're in the 124 honors SP24 repository locally, and we can see that we have Ranjini's code successfully on our computer. Print hello world. So now I see this file, I see all the changes that she has made, but suppose I want to suggest changes to her. I want to add some things to this file, change some things about this file, and I want to put that on GitHub so then Ranjini can go and look at those changes and see what she wants to suggest, like add or not add. So what we can do is if I open up my terminal, so I will do that over here. So let us now gain access to this. Awesome. So now that we have access to our terminal, we can, the first thing that we will have to do before I make any changes to her code is make my own branch. By making my own branch, this will ensure that any changes that I make stay within a safe space so that it does not directly override whatever changes Ranjini has made. And then once we are done with working on my branch, we will go back onto GitHub and merge those changes into our main branch. The main branch where we are right now is the ultimate source of truth. In VS Code down at the bottom here, you can see that we are on the main branch. If you do git status, you will also see that we are on branch main and that my branch is up to date with the main branch from the GitHub repo. So the next thing that we'll do is make a branch. So I actually myself do not remember how to branch using the GitHub the command line. So what I can do in this case is I can go to Google and I can look up how to do basic branching and merging on Git. And Git has amazing documentation for this stuff. So I was looking this up, for instance, and we see here that if we want to create a new branch, we can use the git checkout command with the -b switch. So for instance, we can just go and use this command to create a new branch. So let's do that. So we do git checkout -b, and we can call this branch whatever we want. I'm going to call it Rohan Suggestions. Rohan Suggestions. So it says here that it is not a valid branch name. And the reason that it is not a valid branch name is that there's certain characters that you cannot use when naming your branch because Git doesn't like it. One of these characters is a space in your branch name. So let's try renaming our branch with an underscore instead. Rohan Suggestions. Awesome. So now we see that we've switched to a new branch, Rohan Suggestions. The bottom of my screen also says the same thing. And if I do git status, we can see that I am on my own branch. So this way I am not working with the main branch anymore. I am on my own coding space, and anything I do here will remain in this branch. We will commit to this branch, and only when we are ready to finalize these changes will we merge them to the main branch. Awesome. So let's make a change here. Let's say I also want to print something else out. I want to print out welcome to CS 124 honors. And you know what? I actually don't really like what Ranjini printed out here. Instead of saying hello world, I want to say hello and welcome to UIUC. Okay, so these are some changes I want to suggest to her. So now that I've made changes to her file within my own branch, I will go through the same process to move my changes to the staging area and then push this to my branch. So these are the exact same commands that we saw before. The first thing we want to do is add to our staging area. So the command that we use is git add dot, and the dot is basically a way to tell the command line that we want to add all the changes that we made to the staging unit. So we do that, and that runs successfully. The next thing we want to do is we want to commit these changes. So let's just say our commit message in this case is we modified the print statements in sample.py. Awesome. So you can see here that the message that Git gives us is that there's been one changed file, yep, sample.py, and we inserted two things and deleted one thing, which is, it basically recounts the changes that we made. And the last thing we want to do is git push. So when we run git push, sometimes you might get this error if we don't have the branch set up on our remote stream. So this is basically saying that Git only sees the main branch, it does not see the branch that we have made. So we can just copy this command that it suggests and then use that. So what this does is it will push and set it to make sure that the origin can see Rohan suggestions and then push our change to Rohan suggestions. So you can see here that I've made a change from my branch to my own branch. So everything that I've done is contained within my own branch. Awesome. So let's go see if that how that plays out on Git. So if I go back to my Git repo, we can see here that Git automatically tells me that Rohan Suggestions has recently pushed changes. So if I go to my little drop down here, there's a place where we can see the different branches that we have. So right now it only says the main branch, but if I click view all branches, we can see that Rohan Suggestions is one of them. So I can go here and we can see, hey, these are the changes that were made in Rohan Suggestions. And if I go to sample.py, we can see that my changes have been successfully reflected. Note that if I go to the main branch, so if I switch back to the main branch and I look at sample.py, these changes are not there. And this is important because our changes that we made are specific to my branch only. They have not yet been integrated into the main branch. So the integration will only happen when both the developers agree that the changes can go onto the main branch, which is the ultimate source of truth. So suppose that Ranjani looks at these changes and they're absolutely okay and she's fine with merging those to the main branch. How can we go about that? So with Git, there is a multitude of ways to go about merging, but perhaps the simplest way is dealing with it through the GitHub client, so the website. You'll see here that it says that I have changes like about a minute ago. So I can open what's called a pull request. And a pull request basically just says that it checks to make sure that your branches can be merged very easily. So what this is saying is that I want to take the changes in Rohan Suggestions and push them into the main. So main is trying to pull from my branch. So I can add a title to this pull request. Let's just say modified print statements. And you can add a little description here for your thing. For instance, I can say something like added a welcome to UIUC and modified other print statements or anything that describes your changes. So we can see down here, it shows what the final file will look like. So we'll get rid of the hello world and also print out hello and welcome to UIUC. And it will say welcome to CS 124 honors. So, okay, so now what we can do is we can create the pull request, right? So what this does is it now exists within our GitHub repository. So there's different tabs up here that you can see. The code is where we can see the code. And the other tab that you'll most likely be worried about is the pull request tab, where you can see all the PRs that are open. And in order to finalize the merge, you need to make sure that there are no merge conflicts. And in this case, it looks like there are. So it says this branch has no conflicts with the base branch. and merging can be performed automatically. So suppose Ranjani was here, we would ideally look through this together, and if there were any conflicts, we could edit the file directly in here and make sure that the file looks exactly the way we want it to. In this case, we don't need to because there are no conflicts. And once we agree, we can merge the pull request, confirm merge. Awesome. So now it says the pull request has been successfully merged and closed, and the Rohan suggestions branch can be safely deleted. And the reason it can be safely deleted is because all the changes that were now in my branch have been moved into Ranjani's branch, into the main branch, and there's no need for this branch anymore. So we can delete it. And now if we go into our code, you will notice that Rohan's branch is no longer there. So if I go to view branch, view all branches, it does not exist anymore. And if I go to my sample.py in the main branch, you will see that my changes have now been reflected and everything is all good.